The data warehouse components that we're shipping with 1.0 consist of a back-end infrastructure, front-end reporting application, and a set of defined subject areas and reports. And let me talk a little bit more about those. The subject areas consist of database schemas in both SQL 7 RDBMS and OLAP, 7.5 cubes. A predefined data stream parsing, so the logic and scripts to move the data from the log stream into the database, processing and loading that data. Key predefined reports, 3, 4, 2, 5, some small number of predefined reports per subject area to get the NetOp going. Documentation and metadata, open architecture throughout. So unlike really any other piece of TV server, the data warehouse doesn't really write any code. We hardly ever compile anything. We're really just using SQL 7 and the tools that are included with that, and a lot of scripting to get together. And anything that talks OLADB and OLADB for OLAP can talk to the data warehouse. The primary subject areas that we're working on are subscriber, user, and device. I go on to talk a bit more about those in a few minutes. Web browsing. Web browsing has information potentially at the click level, the page view level for each subscriber, actually each user is browsing the web, both internally in the walled garden, if that concept set up at the NetOp, and also externally. TV viewing. TV viewing is interesting because we potentially have effectively every click on the remote control. We know exactly what the subscriber is doing in their interaction with the television. We know what shows they're watching and how long they're watching them. We're planning to bring in some cable connection data, basically keeping track of how long the box is connected into the service and how much data is flowing up and down. Service performance, client errors are typical subject areas that would probably be used by the backroom NetOp type people. And if the NetOp chooses to instantiate, to use commerce as their advertising engine, then we'll be folding in the commerce for subject areas for the local e-commerce and advertising. Also, if it's possible that we'll have the bandwidth to bring in email, chat, news, games, and other auxiliary and somewhat less interesting subject areas. All the subject areas linked together almost all contain information by subscriber, user, or device. And analysts can conduct cross-schema studies. For example, finding the subscribers who regularly visit these sites and watch the Super Bowl and maybe click through on some interactive TV site. The benefits, the most obvious ones are very simply reporting on the activity of the service. You can also, since we are keeping track of exactly what the subscribers are doing and how they're doing it, the potential for doing targeted advertising both in the on the web and on television, potentially in the future, are tremendously valuable and obvious to figure out how you might do that. Both static and the video ads that are unique, I think, to a TV server kind of service. Customer care is also a place where the data warehouse is going to be valuable. When subscribers call up with questions to customer care, it's pretty straightforward to modify and extend the customer care application to triage the subscribers, sending those who are more valuable to the service to a higher level of customer care call. Customer acquisition and retention. Acquisition is less of an issue, of course, for cable companies, and probably retention is too, than it would be for the telco-based service. But I still think it's useful in general, particularly for upselling to a more expensive and presumably more profitable service. Content and channel decisions, both on the web and TV side. The U.S. service at Web TV has used the data warehouse there significantly for this, figuring out what it is, exactly what it is subscribers are doing, what it is they're interested in, and making decisions about particularly web content based on that. Also decisions about how to structure the company, what kinds of activities to support, and what kinds they can scale back on. And then obviously service operations and economics, I don't give it short shrift, but I think all of us can understand that really pretty easily. What I'm setting up the data warehouse to do is support the big wins. The reporting as a base requirement comes out of building a data warehouse that can support killer apps. But there are easier ways to generate a predefined set of reports than to do what I'm doing, which is building a conform-dimensional data warehouse. So my real goal is to enable the killer apps. I'm not building any killer apps that I see as killer apps for 1.0. I'm enabling the infrastructure for future releases TV server or also for NetApp to build themselves. The killer apps are unique or nearly so to business conditions. They're probably something the really valuable ones are ones that NetApp is going to do themselves. They're often closed-loop systems that will feed back into the operation of the service. And the reason they're hard and that building to support that is difficult is that you need flexible data storage to support problem exploration before you develop the application. And I think this is a great role for a system integrator to work on with NetApp. So the implication of building for supporting these killer apps is that the data warehouse is big. You have to store data at a very granular level to support an unknown variety of analyses downstream. We still do throw out a lot of data, but nonetheless, we're talking about a terabyte of data for each million subs if you store data for 3 months, which is what we have to be. That's going to be our recommended configuration. That will be configurable, but that's what we'll ship with. The design focuses on enabling great OLAP cubes, and we're doing a lot of data work to make those cubes work as efficiently as possible and be as easy for the NetApp to build themselves. And it'll support and enable very straightforward business use development of analyses and reports. The relational database in our architecture really exists as a maintenance area more than anything else. It's where data are loaded, managed, and aligned, and it serves as a middle area between the data coming in and the OLAP cubes, which is where most business users are going to be accessing the data. It's important to keep the relational store there because it'll support new OLAP cubes should NetApp choose to define them. This is far more complicated, really, than it needs to be. But the basic idea is that we have data coming from clients which flow through service logs. We also have services, like the proxy, will generate its own logs. Those all get grouped together into one big event stream, which is primary source of data into the data warehouse. We also have operational databases, the most important of which is the TV server subscriber database, which is data that flows into the data warehouse. This guy over here is a relational database that, as I said, serves primarily the staging service. It feeds the OLAP query service. The green arrows here are possible places for interface with external data. Other corporate databases bringing data in, for example, other information about subscribers that's not relevant to this TV server subscriber database. Or truly external data, for example, demographic data, could also be added to the data warehouse. And finally, instead of just sending data through the query service to the business users, you could potentially populate another data warehouse, perhaps a corporate data warehouse in another relational database if that's what the NetApp wants to do. I mentioned most of these already. The SUD database, or I think it was earlier this week renamed to be called Service Database, is the central schema for dimension that's in almost all subject areas and almost all reporting. It's a complex extract. It's by far the most complicated piece of logic we're working on, but luckily the data volumes are trivial. Talking, for 1.0, we're talking 1 million subs. In the data warehouse world, 1 million something is just not a big deal. The event stream is where the huge volume of our data comes from. The biggest piece of that, or one of the biggest pieces of the content formatting logs or the proc logs. Also, some application, for example, TV viewing is actually logged on the client because the service, of course, doesn't monitor the remote control clicks. It's something that's captured on the client, and then periodically that log information is uploaded into the service. Finally, any of the applications that Mike was talking about here, all of these can and do log information, and some of that information is considered useful enough to store in a permanent, user accessible way in the data warehouse. Other sources, good opportunity for somebody else. Okay, so subscriber user device. The data warehouse retains a history of the end-of-day picture of the subscriber and device attributes. So the things that might change during a day are whether a new subscription, of course, or whether the subscriber has changed the zip code, their service plan, which is very important, their account status, or possibly, the end of changing your account status, canceling your account. We keep every day when those attributes have changed for a subscriber, we keep that history. By contrast, we're keeping only the current billing address in the data warehouse. Don't feel that it's important enough to keep a history of that, especially since a lot of those changes are typos, and anything significant gets picked up in the change of zip. Similarly, for devices, we're keeping a history of when device moves from subscriber A to subscriber B, and when the client version has been updated. That's really important for a lot of queries, especially if the NetOps is doing some customization to the client and they want to look at the performance of the service or the behavior of subscribers before and after a client upgrade. The history of that attribute is tremendously important to retain. About users, the logins for email, only current user attributes are stored. Typically, most queries occur around subscriber and device, fewer around users. Attributes just aren't interesting. And we security in the database to shield personal data from most data warehouse users. I don't know how interesting this is to you, but I'll just run through it quickly. I talked earlier about the complexity of the SUD extract and load, and this is a little bit of an outline of what we're doing. The first thing we do is pull over all static information, all of basically the decode information, the labels associated with duties and plans, the fact that a new plan in general has been registered in the database. We're actually subscribing to it in a replication, getting the information over into the data warehouse database, and updating those attributes, which is a tiny, tiny amount of data. It's possibly only one row every week is what I would expect to see in the volume on it. But we still need to put the infrastructure in place to manage the changes to those attributes. The main source of SUD data comes from a table in the service database called entity events, which is populated by a trigger from the service database. So anytime something happens to one of the major tables, subscriber, user, device, and some of their major subtables, that event is logged into this table called entity events, and that becomes the source of data for the data warehouse, this history that I talked about. And this is done in DTS and logging the fact that we've successfully extracted a set of data. The processing occurs nightly, again, because I'm keeping only end-of-day status on subscriber, user, and device. And on the service database itself, it's the customer's responsibility to back up and prune this table entity events if they decide it's getting too big. I don't think you're really interested. Basically, we need to take information that's coming in a normalized structure from the service database, denormalize it into a far more simple structure that we use in the data warehouse. The reason that it's important to do this is that the goal of the data warehouse design is to support very simple, straightforward querying by business people. If we left the data in the form that it was in the service database, that's really too complicated for people to look at and get. So I make it as simple as possible. It also improves, there's a hit during the processing time. Processing time increases than simply copying data over into the data warehouse. But we make up for that during query performance because we've already put the data together in a structure that makes sense to businesses and that they typically query together. Oh, one of the things that I need to do is map the GUIDs that are part of the service database into integers. This is important, again, to support rapid querying in the OLAP and query side of the house. And we stream inserts into Commerce 4 components for surrogate assignment and loading. So I mentioned Commerce 4 here because I'm using Commerce components as the loading infrastructure for the data warehouse. For the SUD data, there's a lot of processing that occurs in the database using DTS tasks, and the final step of that calls the Commerce DLLs. For the rest of the loads into the data warehouse, the very large volume loads, pretty much all of it is going straight through Commerce and using those components heavily. Okay, so I think probably Jim, maybe next, is going to be talking about the event stream and logging. So I'm not really going to talk about that, but the first bullet here refers to the log infrastructure that Jim's group has put together. The second bullet is to separate out and parse specific event types, putting a clean format database load file. We're currently calling this processing harvesting. And it's really a straightforward executable that reads the event stream, looks for the kind of data that is specific to that kind of processing, for example, proxy events, and formats them in a specific way. This is the place where we hopefully are going to be doing any pruning that's going to occur. This is the first point at which we could prune data. So any of the configuration options that might reduce the amount of data that's going into the data warehouse typically occur in here as configuration, and they're configurable by the configuration system. The most processing-intensive piece of the log data loading to perform key lookup and substitution and load into the RDBMS. This is an extremely expensive operation. Basically, I need to take GUIDs, which are what are logged in the logging system, because that's what is used to identify entities throughout the TV server system. I need to take those GUIDs and turn them into integers. The reason I need to do that is because I'm dealing with terabyte of data, and I need to make all of the changes that I can to improve performance. And moving from GUIDs to integers is a huge performance gain. Key lookup and substitution. So any single incoming data file might have 5 identifiers that need to be substituted. You need to have this key lookup for. And these data files can, of course, be quite large. So this processing is very expensive. And that's the reason that I'm using the Commerce technology here. They've put a lot of time and money into solving this problem. And I'm riding on their coattails. It's great, though, because it is standard Microsoft technology. If necessary, we'll aggregate within the relational database. Again, this is really a step to reduce data volume where sensible in order to improve performance. We'll perform incremental loads of the cubes and run scheduled reports. My hardware, the harvesting and loading that I just talked about, we expect probably by default will be co-hosted with the log aggregator that Jim's going to talk about in a few minutes. It makes sense probably in most cases to keep these pieces of the service code together with the machine that's running the log aggregation and harvesting. The Commerce loaders can either be on that machine or they can be spread across multiple smaller servers. The weak link in my infrastructure is the single large relational database server. I, as yet, have no way around this problem. But this is primarily, as I said before, used as a staging database that populates OLAP cubes, and the OLAP infrastructure nicely partitions across multiple servers. I do need to solve this problem before we scale far beyond 1 million subscribers. So I pretty much already said this. The role of the commerce infrastructure primarily is to load tables, performing very fast loads, very fast key lookups. The core pieces are high performance, multi-threaded, distributed. I have some issues with the technology, primarily that the UI is non-existent. What this means is that for the NetOp to change the schema or add new schema is not trivial. You know, I would love to make it drag and drop, and someday it will be, but right now it's a bit of work. And it's complicated, and right now Commerce is not supporting OLAP, which, as I've said, is my primary query database. However, the OLAP tools themselves really are pretty usable, pretty easy, so I don't see that as a major problem. The TV server is extending the Commerce infrastructure to support table partitioning in the relational database based on union views. We have a tool that will automatically create and drop partitions, generate load scripts, load the appropriate partition, and maintain a view that combines partitions into a single logical view for the business user. We're also managing slowly changing dimensions for subscriber and device. This is the point that I was talking about earlier about keeping a history of changes to the attributes of subscriber and device. That's a fairly complicated thing to model, and unfortunately Commerce is supporting it directly, but we're managing it and integrating that in with the Commerce infrastructure. And as I said, we're using OLAP 2.5. They are not, and we have a different front end than Commerce has for our data warehouse querying. I already spoke about the first tool that we have to support partitioning and loading. We also have a tool to help support the front-end administrative tasks, creating users and giving them security, managing their security, managing the metadata, managing reports, also to categorize sites, which is a little thing. To add a new schema, if the NetOp wants to add a whole schema to the data warehouse, the process would look something like this. Well, first, implicit there, and I should have made it explicit, was they need to do some analysis of the business and figure out what the business problems are and how data is going to support it. And they need to develop a target relational schema, reuse existing dimensions where they're relevant. And it's very important because by reusing existing dimensions, the NetOp is going to be able to define schemas and analyses that cross these subject areas. They need to create a fact table, develop data streams. So this fairly straightforward executable that I talked about that reads the log stream. They're going to need to either change that existing one or write a new one that will pick out the events they want and so reformat them into a more, do any data processing, any data pruning that needs to be done there, and output data in a form that can easily be loaded into a database. For data that's not come from TV server, from some arbitrary external source, simply write an LADB compliant data stream. For example, tab limited rows of data, but really anything that's LADB compliant. Then they need to instantiate the schema via Commerce, develop Commerce load scripts. This is about a week of work. Perhaps supplement DTS packages necessary. Use RMMC to define partitions on this new set of data, schedule the loads, design and instantiate a new OLAP cube or cubes, schedule the incremental refresh, manage the metadata, but develop standard reports. So this is a chunk of work, but it's not impossible. We're shipping a front and with TV server data warehouse, primarily so that users, the NetOps, have a good out-of-the-box experience. We don't particularly expect them to use the front end as their primary corporate reporting tool. It actually is turning out very nicely and is more sophisticated in some ways than what a lot of NetOps will have, because we're publishing over the web, and that's still relatively usual in the data warehousing world. So it is possible, actually, they'll like it a lot and use it a lot, but I don't particularly expect it to be the case. We are basically shipping a website that has integrated metadata where business users throughout the NetOp can access predefined reports. They can change those predefined reports. They can work with them interactively. And they can schedule, basically publish their own reports as well, new reports. It's all database and XML-driven ASP, fully customizable. The customer can add new sections, take away existing sections to the front end if they wish. It's really very straightforward. They can even replace control that displays a report with any other OLADB, OLAP report, or ActiveX control with probably a couple days, maybe a week of work. I have a couple screenshots here that I'll run quickly through. This is, I'm sorry, the only thing I could get up had a one report predefined, but you probably see a full screen full of predefined reports here. We have wizards. We have links to metadata. We have some static reports over on the right. Again, all these components can be moved around as the customer wishes. There's an example of some wizard screens, an example of a report. And again, the report is nice because a business user, so like a marketing analyst at the NetOp, can bring this up in their browser in IE and move these elements around so they can pivot the report, they can change the time period, they can interact with it within the browser. This is an old report that I brought up. The newest thing that we have has metadata showing up on the report page so that the users can see, oh, what is an URL? What does a site URL mean? What does the page count include? I do hope that the network operations people understand that in order to have a really valuable data warehouse, especially if going after these killer apps, you're going to need a data warehouse team, and there's a list of some of the skills and some of the roles that team might include. And I really think that the NetOp can bring up a single killer app. They're going to make up the cost of their data warehouse really quickly. I see the data warehouse as having one-time hard costs of between $1 to $2 a sub. It could be 50% more than that, but it's not going to be 10 times that. That's about right. Ongoing data warehouse team costs $1 to $3 per subscriber per year, which decreases subscriber growth because of economies of scale. And then the benefits when you're working with the NetOp to figure out whether and how much resources they should apply to the data warehouse, have their business people price out a few key applications such as improved ad targeting, reducing churn. A business person should be able to put this together fairly quickly. And any one of these, if successful, will easily pay for the data warehouse. I guarantee it. WebTV has one killer app that has saved more than $3 per sub per month. It unfortunately is based on telco pricing, so it isn't relevant for the cable operations.
We're getting some pushback from this chart. I think we'll start hitting AT&T as we go forward. As we come up with these kinds of numbers, they're going to say that doesn't make any sense. It's not working to us. And it's, you're going to tell me this looks like about $5 a sub a year, $5 a sub a month.
No, $5 a year.
That's not an easy sell. These guys don't have much margin. They're not used to spending money. That is not an easy sell. We need something that's going to convince them that they ought to do the benefit from it. And simply saying data warehouse are a good thing, not it.
Okay. So what about improving ad targeting by 10%?
Examples. Show how and show. We need stuff that will show exactly how it was done, how it worked here, before and afters.
And I think we can get some of that from the service as well.
Yeah. Right, but I mean, we need this.
You need the numbers.
To build out the
I
warehouse.
agree with building.
Also, there's a lot of TCO funds, resources like something has in terms of how to calculate TCO.
Right.
I think we need to get into all that.
Questions? I think that's
I take it the privacy concerns with data warehouse. You can control how much click data you collect, how much is used.
privacy is an issue. And you can certainly control how much is stored in the data warehouse. But controlling how much is actually collected is a harder problem.
Yeah, I think we're going to need to be careful, especially in some regional areas where we'll use for sure.
Absolutely. Germany in particular, big one.
We'll just have to know how to say that, how to message that.
We're talking about that actually with our French favorite clients yesterday, who are also going out in Germany. And they said that collecting it for their own use to do service improvements is not a problem as long as it is not allowed out of house. In France, they can collect anything they want. Even the police don't have the right to ask them for that data. They don't have the right to help to give it to them. Okay. So that means raise the same issue.
Right. I think that's not true. I think that's not true in Germany.
But they said it's not. They said still the stuff they can collect for their own use in terms of maintaining the service is significant. Things like ad targeting might start to infringe on that.
Right.
I'll have to start understanding that.
Yeah. So it's really, as long as we can manipulate what's in there, then it's up to the employment and the net op to comply with the law.
Okay. Thanks, Joy.
Thank you.